Welcome to the ENGR 325 Durability Issues with Asphalt Pavements presentation. The group members of this presentation are Grant, Landon, Braden, and myself, Matt. This presentation will cover how changing temperatures, varying levels of air voids, moisture content, and reclaimed asphalt pavement will affect durability. It will also touch on how bentonite and polyethylene solutions can improve asphalt binders to increase the durability. Asphalt durability is affected greatly due to changes in temperature. It is affected both when it is a mix during placement as well as during the life of the pavement. Rheological behavior of asphalt describes how the consistency and the viscosity is affected due to temperature changes. As shown in the graph, you can see the viscosity decreases as the temperature increases. This results in a soft asphalt when warm and a stiff, brittle asphalt when cold. Hot asphalt becomes very soft and ductile. This causes the asphalt pavement to form ruts and deform from loads applied such as traffic and vehicles. Hot asphalt also results in bleeding. Bleeding is when the asphalt voids are filled with the asphalt binder, which eventually makes its way to the surface of the pavement. In contrast to the hot asphalt, cold asphalt becomes very stiff and brittle. The result of this is cracking in the pavement, as there is less give and less flexibility. Also, if there is moisture present in the voids, expansion occurs when it freezes. This expansion can also cause cracking in the asphalt. Temperature of the mix when it is being placed is also very important. Having the correct mix temperature results in sufficient maneuverability and compactability of the pavement. If the mix is too hot, it becomes fluid-like, which is not ideal for compaction. If the mix is too cold, the asphalt is not easy to place and the quality of compaction is not great. Packing in cold asphalt can result in more air voids in the pavement. Some of the solutions to help counter the effect of temperature changes on asphalt pavement are to use asphalt binders with the proper viscosity to help prevent cracking and bleeding. Also, the underlying structure of the pavement has a large effect on the durability. Using proper subbase material and construction methods is vital for creating a durable asphalt pavement. Moisture content and percent air voids. The moisture content and number of air voids in the asphalt mix play a crucial role in the durability and strength of the mixture. These characteristics of the mix often change depending on the type of aggregate used. The size of the aggregate impacts the amount of asphalt needed. The smaller the aggregate size, the greater the total surface area becomes. This requires more asphalt to cover all of the aggregate. For larger aggregate sizes, the total surface area is reduced and less asphalt is required in the mixture. The absorption of the asphalt is related to the filler content, which is the amount of fine aggregate that passes through the number 200 sieve. Too high of a filler content will absorb too much of the asphalt binder, therefore resulting in too dry of a mix. However, too little of this filler will result in too wet of a mixture. Air voids are small pockets of air that exist throughout the asphalt mixture. They exist in between the coated aggregate particles. Air voids can be expressed as the bulk volume in a mixture. Low number of air voids is most commonly a mixture problem, such as poor quality control and increased binder content, whereas a high number of air voids is the result of a compaction problem. If the asphalt is not compacted enough, the air voids will not be compressed. The temperature during the compaction process also has an impact on the air void content. Low air void content commonly causes vertical consolidation as well as lateral distortion. It can cause an increase in aging and the durability. This is from better compaction and minimized air voids. High air void content can decrease the stability of the asphalt and reduce fatigue life. High air void content increases the exposure for moisture damage due to the large number of entry points for water. This can cause problems for freezing and cracking. All these things contribute to the decreased durability of asphalt pavement. Recycled asphalt pavement mixtures. The process of using reclaimed asphalt pavement in new asphalt mixes has become an industry standard and has resulted in one of the largest recycling systems in North America. In the United States, over 99% of asphalt pavements were recycled in 2014, making for one of the most diligent recycling systems present today. The benefits of using reclaimed asphalt pavements, or RAP, are lower costs of building materials, reduced amount of virgin materials, and a renewable source of aggregates. The majority of RAP is used for pre-existing binder content. A typical asphalt mix with an RAP content will have a weight percent of RAP replace a portion of the aggregate and binder content. Reused asphalt binders have several effects on the performance of the pavements. When comparing different asphalt mixes, the durability can be compared by looking at the serviceable lifetime of each asphalt mix. The two most commonly used methods are hot mix asphalt and warm mix asphalt methods. The warm mix asphalt method is preferred since it has a reduced energy requirement for production, but there tend to be more durability issues. A pavement mixed with a high RAP will have a 20% weight content or higher. The typical durability issues with high RAP pavements are more cracking, resulting in a shorter serviceable life. It was also shown that using RAP can lead to having increased rutting resistance. The warm mix asphalt method is preferred since it has reduced energy requirements for production, but there tend to be more durability issues. Some of these issues with high RAP warm mix asphalt are low resistance to high temperatures, incomplete drying, and moisture damage, making for a lower durability of the pavement. There are several possible solutions to help increase the durability of high RAP content pavements. Increasing the level of detail when grading RAP can improve the interlocking of RAP particles with new aggregates coated in bitumen. Also, new regenerative agents are being developed and added to RAP to help rejuvenate favorable binder qualities of the old bitumen. Other methods such as polymer modifiers and fiber reinforcements are also being explored. Bentonite and polyethylene. Bentonite and polyethylene are two additives to help reduce durability issues related to the asphalt binder. Bentonite mainly comes from volcanic ash in rock form. It is further broken down into a clay-like powder before it is added to the bitumen. Tests have shown significant improvements in the durability of asphalt by adding small percentages of bentonite. Within the first 15% of bentonite added to the bitumen, we see the modulus of resilience increase to 5,390 megapascals, which is a 13% increase. It was also concluded that when too much bentonite was added to the mix, the modulus of resilience would slowly decrease after reaching its peak value, but remain higher than the original sample. The tensile strength is where we see there is a drastic improvement. The indirect tensile strength of the test specimens increased by 24% at 30% bentonite added to the mix. The second additive is polyethylene. Polyethylene is a thermoplastic polymer that is most commonly produced as a plastic. For asphalt, a low-density polyethylene was used to increase the durability and strength of the asphalt binder by increasing the complex shear modulus and the rotational viscosity. The addition of 6% low-density polyethylene improved several properties of the asphalt binder. There was an increase in the ductility of the bitumen, increased strength, and reduction in the penetration. Polyethylene also limited the amount of ductility change of asphalt binders at high temperatures, which allows for an increased temperature range of binder products. Thank you for listening to our presentation. We would now like to open the floor to any questions on the durability issues discussed during our presentation.